Hey everyone, today we will be seeing how we use Shapley values to explain machine learning models. So Shapley values is actually a concept from cooperative game theory and it won the Nobel Prize in Economic Sciences also in 2012. So today we will just be looking at what Shapley values actually are. We will not be looking at the implementation of SHAP. That we shall look in a different video. So before we actually go into the math of it, let us just understand the gist of it using a very simple example here. Let us say we have a random forest and your model and you are predicting the number of rented bikes for a day given your weather. So you can see that here you have all your black. All right. So here you have all your features here. And what we are trying to explain here, what Shapley values essentially try to explain is the difference. So it doesn't actually explain how much each feature contributed to the outcome. It explains how much each feature contributed to the difference in outcome when compared to the average prediction. So this was the prediction for this day and this was the average prediction. So Shapley values explain the difference. Alright, so you can see here in this example that most of the reduction in the average prediction is coming actually from the weather, like since it is rain, snowstorm and it's very humid. So most of the reduction in your actual prediction is coming from these two features right here. Alright, so now since you guys have understood what is Shapley value, so let us go and look at how it is actually calculated. So don't be a bit afraid of this formula here, even though it looks a bit complex. We will break it down into very simple terms using a simple example. So first of all, why do we even need this? So let us say you have only a linear model. Let us say we have only ax plus by is equal to some z, where z is your outcome. Here you have only two variables, number 1 x and number 2 y, and you can clearly see here that x is whatever the value of x is coming, this much is being contributed by x to this outcome and this much is being contributed by y. But what if I give you a slightly more complex equation? Let us say something like axy plus bxy square plus cy square is equal to z. So how can you identify how much x is contributing and how much y is contributing? So you see that it's becoming very hard to separate the contribution of each feature individually here. And this is like a simple non-linear equation. We have much more complex equations in all the machine learning models that we use today. So that is the reason why we need Shapley values. And let us see how Shapley values are calculated. So Shapley values is calculated by this formula right here. This one, let me just change my pen color. Okay, so this formula right here. So before we go into a worked example, a simple worked example with this formula, we shall try to see what this formula is trying to simulate. So you can see the interpretation. It is the formula is trying to simulate the marginal contribution. So again, what is marginal contribution? Marginal contribution is nothing but the difference in the actual prediction versus the average prediction. So that is the marginal contribution. So let us take a simple 3-player game or 3-feature example here. So let me just change color. Okay, so let us say there are only 3 players, P, Q and R. What this formula essentially will try to simulate will be how and let us say we are trying to calculate how much R contributed, the feature R contributed, marginal contribution of feature R. So we are trying to simulate how feature R is contributing when it is interacting with the other players to this outcome. So for now I will be ignoring the weighting term here. This term I will be ignoring this term here for now. We will only try to see what this term is simulating, this term. So when I only try to simulate for that term, alright, so what will it be? It will be V of PQR minus V of PQ. So here R has interacted with both the players. And then let us say he has not interacted with Q, or Q has kind of not contributed well to this game. Q has played kind of average. This V of P. One more scenario can be Q has played somewhat, contributed somewhat positively or negatively, and P has contributed on a very average basis. So again that can be simulated like this. V of R. And last again, like both P and Q have played very average, only R has contributed either positively or negatively. That can either be, and then that can be simulated like this. So when you add all of these together, what you finally get is how is the Shapley value of R. So what this, oh, I made a small mistake here, so this should be Q actually, I'm sorry. So what we are trying to simulate here, as per this example, I hope you guys have understood this example. So we now have seen how R has performed in different situations when he has either P or Q have played well or have played bad. So played well or played bad is just what they have actually done in this outcome. So we are simulating them not having any effect by taking the average value. So let us say Q is missing here in this example. That just means that we are taking an average value of Q, and I will work it down in an example also for you guys. But so this is the gist of that formula, where we basically try to see how one player interacts with different subsets of other players. So you can see here that was PQ subset, only P subset, only Q subset, and then like no, this is just a null set, or no player has played any significant role except R in that outcome. Alright, we'll see how to simulate this next. Okay, so coming to the final worked example. So let us go back to our simple two-player game. So let us say only two players, X and Y, or two features. So I am taking a linear example here because we kind of know what the outcome should be in a linear example beforehand. So let us say we are calculating the Shapley value for Y. For a linear example, we know the value should be P of Y minus P of expected value of Y, or the average value of Y. So this is the marginal contribution of Y in this particular outcome, whatever it actually contributed, this one, minus what it has been contributing on average for all the instances that it has been in. Alright, so we will try to come to this outcome using the formula above, the Shapley value formula. So what can be the different kind of interactions here? So there can be two major interactions. We have V of xy minus V of x. I am again ignoring the weighting term, we will get to that at the end, and V of y minus V of 0. Here we have seen how y is interacting with x has played a significant role. Here y is not interacting with x has not played a significant role. And what is v of xy? V of xy. What is the marginal contribution of y when it has interacted with x? So that will be nothing but ax plus by minus expected value of ax plus by. That is nothing but ax plus by. Let's say expected value of x. Sorry, minus b expected value of y. Alright. So what is v of x here? Now this is coming here. What is this here now? So that will be ax plus b expected value of y, because vx we are assuming that y hasn't played a significant role here, or he has played a very average game, minus expected value of ax plus by. So that will come out to be ax minus a expected value of x. So this and this will get cancelled. Now similarly vy will come out to be by minus b expected value of y, and v0 will come out to be 0. So when we add all of these up, what do we get? When we add let us say 1, this will be 2, this will be 3, and this will be 4. Yeah, so what do we get when we substitute all these terms back here in this equation, in these two equations here, right here, and add them back up? You can add all these 1 2 3 4, and you will notice that we get 2 times of by minus b expected value of y. So this is exactly where that weighing factor comes into place, the weighting factor that I have ignored till now. See this one right here, this one, the weighing factor. So you can work it out that weighing factor will come out to be nothing but 1 by 2. So the weighing factor is nothing but just 1 by n minus 1 c yes, where n is the total number of players that you have, and s is the number of players in the current subset that you have chosen. So this is done just because if we can go back to our 3-player example here, you see that R can interact with all the players, that is p, q, only once, but he can interact with p once and q once. So you can see that this interaction has happened twice here with only one player, but with 2 players it can only happen once. So that is why we discount this by like half, and we like give it this weightage as 1, so that when we add them all together it kind of gets equal weightage. Here we saw that for a 3-player example we have calculated how many, like let me just count it here, like you can see 1 2 3 4 5 6 7 8. We have done 8 calculations here. So the number of calculations we have to do increases with your number of players as 2 power n, as here it was 3, so 3 players, so 2 power 3, we have done 8 calculations. So you guys can see that for larger number of features, let us say 100 features and all, this is not possible. So that is why we use a slightly different version of this in the Sharp implementation. So we will discuss that in the next video. Alright, so I hope you guys like this video. If it has cleared up some confusion, please like the video. If it has confused you even more, go ahead and dislike it, it's alright. Alright, see you guys, bye.